In this video, I will show you what the Ruby programming language is capable of with respect to solving problems we would otherwise require the singleton, proxy, or interpreter design patterns for. And also in general, what we can do with the language that has the features that Ruby has with respect to openness and ability to hook into certain deep places in the language. The scenario is this. We have a build tool which can build and configure, update, and migrate databases for a set of different products in a set of different environments. So we want these tools to be configurable, and we would want this tool to do a great many things. There are many interconnected steps that build on one another, and we would like to have a uniform way to access all of these different steps. So in one case we might want to build product A, in another we might want to upgrade an entire application of type B, and upgrading that application might mean we want to build the app, package it so that it can be distributed, update a database, and finally send an email to someone about the progress, if this is a nightly build, for instance. In the file we're looking at, we see a number of build steps that can be connected to one another. In Ruby, this is a method invoked with an argument and a block of code as another argument to the method. So we don't have parentheses, but we could add parentheses if we'd like to. It's optional. So one of the parts of this code is to set up some options for sending email. We create a hash object with address and possibly port, domain, username, password, and authentication configurations for the current setting. Now, we do this by referring to what would otherwise be called a static method, a method on the constant called mail. And this constant is a class. It resides in the namespace or the module in Ruby called conf. So in the namespace conf, there's a constant called mail, and it has a method called host. So there are some out-commented configuration options, but some essential ones we need to provide are from and to addresses. When we create a mail object, we need to have from and to. Okay, so how does this look like then in code? Here's the definition of the mail class. It's empty, but it inherits from a class related to all configuration, all types of configurations. In this case, we have a corresponding configuration file that looks like this. It contains keys for host, port, from, and to. And the format is very straightforward. Key, value. There are other ways to format a configuration file written in the YAML format, but this one will do just fine for our example. So somehow this example does work, and we're able to retrieve values for from and to from the YAML file that connects to our Ruby class. Somehow Ruby allows us to dynamically generate methods, or alternatively interpret method invocations in such a way that we don't get an error, but rather we get the appropriate values for the corresponding keys in a YML file. The mechanism is hidden in YAML-conf. YAML-conf is defined in this file, where we say that we have a method conf, which simply loads, if it's not already loaded, the configuration file corresponding to the name of the current class. So in the case of the mail class, the simple name of that class would be mail without a capital M. Now, then there is an index method, which means we look up the key in our dictionary we've loaded. And for any other method, Ruby allows us to specify a way to capture missing methods and say that if we don't have an existing definition of this method, then it probably means either that we want to assign a value to some key in our dictionary, or that we want to look up the value. And loading means that we load from a configuration directory based on the name of the current class and so on. Now, remember that we didn't create an object of type mail. We didn't create an object by using the new method, but we applied the from and to methods on the mail class directly. So there has to be a way for us, if we say that for all instances of a configuration of a YAML-conf object, we have this way of looking up unknown methods, or rather treating unknown methods. But for the class itself, Ruby has a way of creating a singleton class for any object. And creating that singleton class is done by saying, after the class keyword, having these double less than signs and then the object we want to create a singleton class for. And in this case, self means the constant YAML-conf. So we extend YAML-conf itself with two methods. And we say that first there is, well, the singleton, a method to obtain a singleton, and then a method missing declaration, so that any method invocation not known to this YAML-conf object or the inherited mail object should result in sending the method to the instance itself. And the instance then, the result of applying the new method, new, which creates an object of type YAML-conf or of type mail in the case of the mail class, leads to having an object that can respond to this method missing. So this only applies, the default behavior of looking up values in a hash only applies when there is no other method defined. So we're free to say that, well, we can have other methods in our class, and we can also overload method missing. In this case, the command configuration is a little special because here we don't specify constant values. We use something called the globs, in which we have patterns that can be expanded. So this should be expanded to either programs, program files, x86, and so on. There are a number of different folders on Windows systems. And each of them might have the same structure below the first level, where we can find, for instance, the Team Foundation server client tools and Team Foundation Power Tools, and other related tools as well. We might also restrict ourselves to only including directories which match 10 or 11 as a version number. So building using Visual Studio's tool can only be done if we have Visual Studio 10 or 11, not 9, for instance. So this is a glob, and the way we use it in our command class, which then may receive method calls to look up commands according to the keys we have here. So we might write command.tf, command.tfpt, and so on. In this case, we have a special structure which contains our actual paths, if we've found any, and unless we find the path, we raise an error. Otherwise, we select the first match to the paths that are the result of expanding the glob. So this is one way of creating a special kind of configuration. And another example, we use, in this case, we use the sign tool command. So sign tool should be a key in command.yml here. And when using it, we expand the path and return the looked up one by using method missing. Method missing means we have a proxy. We can generate proxies for different objects. We don't have to specify new classes, but we can say that for this class, we dynamically either define new methods if we want, or capture invocations to non-existing ones. Another design pattern we could see was the use of singleton classes, which allows us to create singleton objects if we would want. We can also see that Ruby features this key concept of capturing unknown method invocations. So using these language features, we don't have to write our separate interpreter for our configuration file format. And we can use the values in these configuration files as if they were, as if they were regular methods in a class that corresponds to our configuration file. So these are some examples of what can be done in the Ruby programming language, and we can compare that to how we would solve similar problems using design patterns such as interpreter, proxy, or singleton in Java, C++, or C#.